There is something that goes wrong sometimes when we go to convert a fraction to a decimal. And that is that the decimal division goes all weird. Let's see what I mean by that. So I'm going to convert 4/11ths to a decimal. Put in the decimal point, add a 0. 11 goes into 40 3 times, with 7 left over. 11 goes into 70 6 times, with 4 left over. 11 goes into 40 3 times. This is familiar, with 7 left over. 11 goes into 70 6 times, with 4 left over. Wait a minute. This is just going to keep happening, right? Every time I write a 3, I have 7 left, so I'm going to write a 6 next. But every time I write a 6, there's 4 left, so I'll write a 3 next. This pattern of 3, 6, 3, 6, 3, 6 is going to repeat forever. We have a way of writing that. We put a bar over the pattern that repeats. Now, the pattern might be in various lengths, and it might not start immediately. So for instance, if I write 1/3 as a decimal, 3 goes into 10 3 times, with 1 left over. When I see the same remainder, I know that I'm done. 1/3 is 0.3, with the 3 repeating forever. 7/12ths as a decimal. Let's see. 12 goes into 75 times. 12 goes into 100 8 times. 12 goes into 40 3 times. And now I see the remainder 4 has repeated. There's only one digit between where my remainder repeats. Only one digit is going to repeat. 7/12ths is 0.583 repeating. So we can see long patterns, we can see short patterns, we can see patterns that don't start immediately. And our clue for when the repeating pattern starts is that the decimals will start to repeat as soon as the remainders start to repeat. And that's actually the most interesting fact here, because that tells us that when we convert any fraction to a decimal, that decimal will either stop or repeat. Why? Because each remainder is smaller than the denominator. So if the denominator is 12, there are only 11 possible remainders, which means if I keep going for 12 steps, I'm going to see the same remainder twice.